Good evening, guys. This is Professor David J. De Los Reyes. My topic for tonight will be algebra. This is just a simple problem on the so-called a problem that involves exponents. Okay. I will try to discuss how we attack this problem in real life. I've been an engineer for a long time. There are problems in which we do not have to use the so-called laws of logarithms or laws of exponents. There is the so-called solution by using brute force, that is, by using trial and error, if you are sharp. Because if you are not sharp, trial and error will be not so good for you. Okay? But for me, sometimes I prefer trial and error. Sometimes if we are rushing things, like maybe if you are on the SAT exam, maybe just a joke. Okay, my topic tonight is algebra. I will just illustrate a simple problem in which the given problem is of the form exponential form, something like that. Okay, I will try to give you the problem. If we are given the equation 2 raised to x plus 3, the exponent of 2 is x plus 3. It's an algebraic function. And the right hand side, I don't want to complicate matters. I could add up some more things on the right, but I want it to be just simple, because what is important here is the concept on how to solve this one. Okay? I will repeat the equation. 2 raised to x plus 3 equal to 128, and the problem is asking what will be the value of x. I will present two solutions. Solution number 1 is actually the solution. It's just like if you are in the board exams, okay? The proper solution should be solution number 1. Solution number 2 will be fine, but it's a trial and error. If the value of what you are looking for is not exact, you're in trouble. Okay? But if the value of what we are looking for is exact, we could use the trial and error. Okay, I will present solution number 1. Solution number 1, that is using logarithms. There are two types of logarithms. It is the common logarithm in which the base is 10, and the other logarithm is actually the natural logarithm, ln. The proper way on how to read this one is not ln. It should be natural logarithm. Okay? In short, if you're rushing, ln will be fine. It is understood to be natural logarithm. Okay, let's try to bring out solution number 1 using logarithms. I rewrite the given equation, and to proceed with the solution, okay, using logarithms, I prefer natural logarithm. Not that I am afraid of common logarithm, it's the same. But for electrical engineers like me, we are always using natural logarithm, like in the calculation of the length of transmission lines or sub-calculations. Those involves exponential functions, and exponential functions is related to actually natural logarithm. So taking the natural logarithm of both sides, the natural logarithm, okay, just be careful. The given exponent is a little bit with the quantity, so we use a bracket thing to pinch this one. So the natural logarithm of open bracket 2 raised to the quantity of x plus 3 close bracket equal to the natural logarithm of 128. What you will do on the left, do it on the right. Okay? The left hand side can be simplified as x plus 3, the natural logarithm of 2. Why is that so? Because the natural logarithm of, as an example, of x to the n can be written as n, the natural logarithm of x. We could bring down the exponent, so this is the exponent now, times the natural logarithm of the base. We follow that one. That's a laws of logarithm. So those YouTubers who are emphasizing the so-called laws of logarithms, this is it. Okay? So the natural logarithm of open bracket 2 raised to the quantity x plus 3 close bracket equal to the natural logarithm of 128. The left hand side, as I mentioned a while ago, can be written now. We could bring down the exponent. So this is x plus 3, the natural logarithm of 2 equal to the natural logarithm of 128. Okay, dividing both sides by the natural logarithm of 2, left hand side will just remain x plus 3 equal to the natural logarithm of 128 over the natural logarithm of 2. Okay? The natural logarithm of 128, okay, you cannot memorize that one. There is no trick on how to compute for that one. Maybe using the Taylor series, maybe, but it's a complicated thing. So if you are on the examination, just bring out your scientific calculator. Punch out 128 here, then press the natural logarithm. It's 4.852. Then punch out 2, press again the natural logarithm. What comes out is 0.693. 1. Dividing this one here, x now will be equal to, this is it, there is a 3 here, right? And we are solving for x. So x now will be the ratio of the natural logarithm of this minus 3. We transpose this on the right. So this is actually, this is exact. Okay, so this is 7 minus 3. So x is actually equal to 4. So the unknown value of x is actually equal to 4. You could try this one because to check the validity of answer, you just place it 2 raised to 4 plus 3, that will be 7 equal to, is it equal to 128? It is something like that. This is where the trial and error solution emanates. Assume a value of x and pray to God that the resulting value of the left hand side will be equal to 128. That's why I place it here. There is a question mark. 2 to the 8 is 2 to the 7 is actually 128 because 2 to the 6th power is actually 64. You multiply that again by 2, that will be equal to 128. Or if you're not sure with your laws of exponent, just place 2 here. Put y to the x, okay, and put the value 7, and what comes out should be 128. So this is 128. So the value x equal to 4 satisfies the given equation because what comes out on the left hand side is 128. I will not ask anymore if it's equal. It is really equal to 128. So the unknown value of x is equal to 4 using natural logarithm. Okay? Okay, I will try to present the second solution, and this is the so-called trial and error. If you are on the SAT thing maybe, or you are bragging with your friends in which what will be the value of this one, and you don't have anything with you, you could use trial and error, right? Okay, solution number 2. For the meantime, I will assume that the value of x is equal to 2. As a trial, okay, it's a calculated guess, right? So if we put x to be equal to 2, this will become 2 raised to 2 plus 3 is actually 5, right? So this will become 2 to the 5th power. 2 to the 5th power is actually just 32. And this is not equal to 128. So the value x equal to 2, okay, is a wrong solution because 32 is not equal to 128. Okay? Meaning to say, we will go higher. Okay? Use your intelligence, right? So if x equal to 3, this will become 2 raised to 3 plus 3. 2 to the 6 is actually 64. And this is not equal to 128. Right? So meaning to say, the value x equal to 3 should be is lesser than the correct value. We assume for the last time that the value of x equal to 4. If x equal to 4, this will become 2 raised to 4 plus 3, which is 7. And luckily, 2 to the 7 is actually 128. So, after 3 trials, Okay, by using your intelligence. It is a must that you should go very near the correct answer. You can go trial and error 20 times. That's no good. 3 trial and errors, you should be near the correct answer already. Okay? So after 3 trials, for this example, I am just illustrating it. If x equal to 4, 2 to the 7 is 128, so 128 is equal to 128, so the correct answer for x should be x is equal to 4. That's it. We need only 3 trials to go very near the correct solution. If you go 20 times, you're gone. Okay, we are not using your intelligence. It seems we are not engineers or we are not mathematicians, That's it, guys. So it's either using the logarithm, this time it's natural logarithm, or using the trial and error. Supposing the value of x is not equal to what you call this, it's not exact. It will be something like this. During the old times, when we are calculating the value of a sine function with the second thing on the last part, meaning example of it is 3 degrees, 24 minutes, 10 seconds, okay? On the value of those using tables, okay, you could not find the exact value of those. So we use the so-called interpolation. This is A, B, C, D, this is E, F. We do like this, okay? We assume the first value, then we take the difference. And then again, we assume the next value, which is higher than the correct one, then we compute for the difference. Then it is something like this. If this is given, and this given, this given, and this is unknown, so actually we could use ratio and proportion maybe. Something like this value here over this value should be equal to this value over the one we are looking for. So we use interpolation if the value of the unknown is not exact. But if the value of the unknown is exact, it will come out as can be seen from here. So if the problem, the unknown is not exact, we use interpolation. You assume first a certain value, then take note of that. Then again assume another value, then take note of that. Then try to interpolate. We call it interpolation. Those were the old days when calculators are not yet available and we are still using tables of trigonometric functions. Like in the calculation of sine of what you call this, example of it, 30 degrees, 12 minutes, 14 seconds. Because in the table, maybe you could look for the sine of 30 degrees, 12 minutes, but without the 14 seconds. In the old days, you should know how to compute for the value of sine of 30 degrees, 12 minutes, 14 seconds by using interpolation. So in the trial and error, if the unknown is not exact, you could use interpolation to go to the exact solution. Okay, good evening, Los Angeles.